So definite integrals, I'll pick question A and then question F. So question number 3, the integral 4 minus 3x dx. Okay, so the integral of this is just the same as using linearity property. Just say the integral of 4. You can just change this. So it is 254 dx minus integral 3x dx from 2 to 5, where our lower bound is 2 and our upper bound is 5. So this is just the same as 4, 1, 2, 5 dx minus, I can just pull out 3, 2, 5 x dx. So the integral of the constant is x. Okay. I'm saying x because x is the variable that we are using in that equation. But if I it was z, I would have said z. If it was y, I would have said y. But now that we have x as our variable, that's why I've said x. So x, our limit 2, 5 minus 3 x, 1 plus 1 is 2 over 2, and our limit here is from 2 to 5. So while there's x, when there's x, we put a 5. So we'll say 4. When you put a 5 here, okay, 5, then the lower limit is minus. You put 2 where there's x, to be 2 here. So we are done with this part. We move to this second part, minus. So I'll pull out the constant here. I'll pull out 3 over 2. So I just remain with it. X squared. So while there's x, we put a 5. So it will be 5 squared. 5 squared minus, while there's x, we put a 2. So it will be 2 squared. 5 minus 2, we have a 3. Multiplied by 4 is 12. Then this is 25, and then that's 4. 25 minus 4. That's 21. 21 multiplied by 3. You're going to have 21, 3, 63. So negative 63 over 2. So you have 12 minus 63 over 2. You can finish it up where you're going to have 224 minus 63. So here, if I add the 1 here, I'll have 2. Then this will give me negative 40. So now, since I put the 1, so I'll just say 39. So it's negative 39 divided by 2. So 24 minus 63 is negative 39 divided by 2. You can finish it up.
Madam.
Yes, and let me just pick this 4. Sorry for that, guys. For now, that's all about that question. There was someone who wanted to ask me a question before the call.
Madam, I'm not very clear. How did you differentiate that 4 to give it an X? And then the 3.
No,
How
you
did
have
it
to,
now become
one thing
X
that
squared?
3, which is here.
And the 4 it didn't have an X, now it has an X.
My God. Okay, guys, it's like this. You have a 4 here, you have a 1, and then the X. So now, let me just ignore this 4 which is here. I leave the integral of 1. What is the integral of 1? Give me the answer for integral of 1.
X.
The integral of 1 is X. So it's X. Here we have, here it's X. But here we have a 4 outside. It's 4. So what is 4 multiplied by X? So this 4 is multiplying whatever you're going to get, whatever you get here, multiply it with this 4. That's what it simply means here. So whatever you're going to get after integrating, multiply it with this 4. So you got X as the integral of 1, and then that X multiply it by 4. You're going to have 4X. Are we clear on this one?
Okay, and then the 3. And then how do you have now 5 minus 2?
Okay. So for 3, so now let me pick that okay as well. 2, 5x dx. So now this negative 3, which is outside, I'm going to cover it like this. So I want you to give me the integral of x. What is the integral of x?
X squared.
X squared over what? Because what you get here, you also have to divide it.
Over 2.
Over 2. So now this that you have here, multiply
Over 2.
What is outside here. So this multiplied by negative 3, what are you going to get? You have negative 3x to the power 2 over 2, like that. So now that you have this piece which is here, I can now just concentrate on the variable, because what we have here, this limit here, you're just going to replace this limit where there's x. So where there's x, that's why we replace our limit. So now if I happen to write this like this, there is no difference. It's just one and the same. Or even the way it is, I can do this. Now I put my limit. The upper limit that I have is 5, and the lower limit that I have is 2. So my upper bound here, it simply means that in this function here, where there is x, I have to put a 5. So now you start with the upper bound minus the lower bound. So so where there's x here, when you put a 5, you're going to have negative 3 multiplied by 5. 5, x is 5, but this x is raised to the power 2. So it will be 5 to the power 2. So you're done with the upper bound. Now we move to the lower bound. So now since we're talking about the lower bound, there's minus. So now, before I do that, let me just factor out this negative so that you don't get confused. You can just do this, sorry. Let me just factor out negative 3 over 2. Negative 3 over 2 is outside, meaning that whatever we are going to get, you have to multiply negative 3 over 2. So here we are going to remain with the x squared, like that. 2 and 5. Then this, I will just bring it here. Now I start the business. So what is x here? What is x? You put a 5. You're going to have 5 squared. You're going to have 5 squared because it's x to the power 2. Now next, for us to use this lower bound now, it will be minus. It is a minus, it's b minus a. So here it is 5, this upper bound minus lower bound. So the lower bound, it will be minus, where there's x, we put a 2. So it will be 2 squared, like that. So 2 squared, 5 squared is 25. 2 squared is 4. So 25 minus 4, it is 21. So this piece here is going to give us 21. Now 21 that you are going to get here, multiply it to this that we have outside here. So 21 multiplied by -3 divided by 2. That's what we are going to get. That's what we are going to get. How we got it? -63/2. Are we clear?
So, madam,
Yes.
yes, it would be the same if you let's say you said 4x, you put in the 5 alone, and then you come and do math. I'm saying it would be the same if you said 4x.
4x.
Like 4x, you put in the 5. You say
I put a 5.
4. Yes. And then you do minus 4, you put a 2. Is that the same thing?
Yeah, because 4 is common here. When you factor it out, it will be 4, open bracket, 5 minus 2.
Okay. You can do this all the time. Or that's in this case.
Yeah, no, you can do it all the time.
You do this all the time.
Yeah, every time when you happen to have a coefficient, when you happen to have the coefficient of this integral, yes. So this coefficient simply means that whatever you're going to get here, you have to multiply with this. So even here, when you have the coefficient outside, you do the same here. So let's look at right. So I is equals to 3x minus 4 squared over 3x plus 1 dx. So when you look at that,
Madam, could you move your camera up?
If I try to expand it, so the way it is, if I tell you to expand this, we are going to have this situation, x squared. So when you square this, remember, I'm expanding the top part. So here you're going to square this term, you square that term, and then lastly, you're going to multiply 2 multiplied by this term, multiplied by this term. That's how we expand when you have 2 there as a power. So now we start with this part, which is this. The next thing plus -4 squared. Then next, it is this multiplied by this. So 3x multiplied by -4, which is -12. -12 multiplied by our power there, we're going to have negative. It's -12x. -12x multiplied by 2, it will give us -24x. So we have expanded the top part. So this would be 3x plus 1. And this will give us a 9x squared minus, it will be plus 16 minus 24x over 3x plus 1. So now when you have this here, so you have to know the difference. When you have, for example, if it was just, then if I told there was no plus 1 here, if there was no plus 1 here, we would have just differentiated, we would have just divided these terms by this denominator. I would have said 9x squared over this, 16 over this. So here, guys, when you see something like this, so here we have to decompose this into partial fractions. So as you can see, here we have x squared. The highest polynomial here is 2, and here it's 1. So here we are expected to use long division first of all before we decompose it. Are we clear? I'll put the limits later But for now, let's just see. Let's deal with the integral. So we are going to decompose this into partial fractions. So decomposing this into partial fractions, we are going to, first of all, since the highest polynomial for our numerator is bigger than our denominator, we are going to divide. We are going to use long division or any method that you are conversant with. So if at all we say 3x plus 1, 9x squared plus 16 minus 24. Can we say minus? I write them nicely. 24x plus 16 x squared. 9x squared divided by this, you're going to have 3x. So 3x. 3x multiplied by 3x is 9x squared. 3x multiplied by 1. 3x multiplied by 1 will give us plus 3x minus, this will give us a 0, negative 24x minus 3x, that's negative 27x. I'll bring down this 16 plus 16 down, I'll bring it down. And then negative 27x divided by 3x, that's negative 9. This multiplied by this, we are going to have negative 27x. This and this is minus 9. Then this will be 0. And then this will be plus 25. So this will be plus 25. So now, remember what we were doing last week? How we're solving the partial fractions. So what we have here simply means that this 3x plus 9, 3x minus 9, like this, plus our remainder 25 over this that we have here, 3x plus 1. This is equals to this piece which is here. So now instead of us going with this, we'll go with that. So we've decomposed it into partial fraction. So we can solve. Yeah. Since we have 25, and then this piece which is here. Yes, So we have decomposed it into a partial fraction, or we have just divided it. Are we together? Are we together with the way we divided? Anyway, what you do here, just divide. But here we are lucky because there we have 25. Already the value of A has been found, so there's no need of us to go as far as expressing it as a partial fraction. But with this that we have, we'll be able to integrate this. So now instead of us going with this, we'll go with that. Because when you look at this, when you multiply this multiplied by that, it will give you 9x squared. 9x squared. This multiplied by this, it will give you negative 27x. 1 multiplied by 3x is plus 3x. 1 multiplied by that is negative 9. So you're going to have 9x squared. Okay, so 9x squared. Remember there's 25 there. So 9x squared. This and this will give us negative 24. And then this and this will give us what? Plus 16. Over what? What we have there? 3x plus 1. So this is just the same. So now this is the same one start. So I'll wrap this part here. And let me just write this. After I've decomposed it into partial fraction, now I can say the integral from 0 to 2 of x, 3x minus 4 squared over 3x plus 1 dx. This gave us the integral 0 to 2. What we had on top, it was 9x squared minus 24x plus 16 over 3x plus 1 dx. Okay, this is equals to what we have here. Integral from 0 to 2. Here we have 3x, was it minus 9, 3x minus 9 plus 25 over 3x plus 1, and then dx. Now the way it is now, we can now chunk this. Using linearity property, we can distribute the integral across here. So this part here is just the same as integral of 3x 0 to dx minus integral 0 to 9 dx. This is, I can factor out 25, integral 0 to 1 over 3x plus 1 dx. Are we together? So what we have here now, we start with this part here. Integrating this part here will give us 3x squared over 2, our limit from 0 to 2. We come to this part, negative. I can bring out 9 this side, so I'm going to remain with a 1. Integral of a 1 is x. So negative 9 multiplied by x, we get negative 9x. Our limit from 0 to 2. We come to this part here. So here it is plus 25. I can factor out 1 over 3, and I'll remain with 0 to 1 over x plus 1 dx. Who can give me the integral for 1 over x plus 1? What is the integral for 1? 1 over x. Yes.
Won't that give you x plus 1 over 3 or something? Since it's 3x plus 1.
Oh, so it's 3x here. I thought maybe this 3 was outside. Okay. 3x. Won't it give us what?
The integral of that one would be ln of who? 3x plus 1.
Ln of who?
3x plus 1.
3x plus 1.
Yes. In modulus form.
Okay, even like that, it's fine. But remember, when you are integrating something like this, here we have the cos. So you have to make sure that you have to know the difference between 1 over x plus 1 when you're integrating this. So this is just the ln of x plus 1. Because when you differentiate this part, it will still give you a 1. So 1 divided by that will still be the same. But now when you have 3 here, it will be ln of 3x plus 1. Now we will differentiate this part here. It will be 3. The answer you are going to get after you've differentiated, you have to divide it here. So you have to divide it here. So this will give us what? 3. So this correct here. That's how we differentiate it. So that when you multiply, yes. exercise. You can go ahead. I'm getting very many with how many minutes? 3 minutes. Okay, you can go ahead.
Madam, I'm lost.
Yeah,
I'm
go.
confused.
Okay.
How I get how we divided and we now got 3x minus 9 plus 25, 3x plus 1. How are you also integrating 25 over 3x plus 1? Why not just doing partial fractions for 3x? Ah, okay, I'm lost. I don't know what's happening.
25 here.
Starting from there at the top, why is 3x minus 9 plus 25 over 3x plus 1? And then how it now
So
became
what?
all
Okay,
that.
what we were doing here, which was just the integral of this part minus this. So when you get the answer, this answer we've gotten here, we're going to multiply it to 25. We have not yet multiplied it to 25. We just integrated it first of all.
I mean from the top there and then coming down. What there's an equal sign.
From here.
Yes. From there, that's when I got lost.
From here, what you do is you distribute this, you distribute the integral across because due to the linearity property. So meaning that this, when you distribute this across, you're going to have integral of this on its own, integral of that on its own, and then integral of that on its own. So meaning that you're going to have 3 of these. The first part, the first term, the second term, and the third term. Then here, this is direct, I'm sure. This is, when you factor out 9 here, you're going to remain with integral of 1. And the integral of 1 is x multiplied by -9. We have this -9x. Now here where there's 25, and we have 1 over 3x. So here you have to note to say, when you have, let's say for example, you have ln of, when you have y is equals to ln of x. Y is equals to ln of x. Let me just write it somewhere here. So you say y is equals to ln of x. So the dy over dx here, dy over dx of this, dy over dx of this is 1 over x. So dy over is 1 over x. So when you multiply this here, when you differentiate x here, it is to give us a 1. So we just make it be like this. So now what if I told it was y is equals to ln of 2x. So y is equals to ln of 2x. It is y prime is equals to ln equals to 1 over 2x multiplied by the differential of this here, 2x. So it will give us what? To give us 2. It will give us 2. So that and that cancels. So this will give us y prime is equals to 1 over x like that. So now when we integrate this piece which is here, integrating this so that it takes us back to 1 over x. So when we integrate 1 over x dx,